Hello, in this lesson we're going to program a FPGA to write characters on an LCD, specifically on the MAX II development board revision 2. Here's the video with the project done. We could write the word hello. In the MAX II board, development board. The goal is to write in the LCD. The language is Verilog. We use a pre-made driver to help. The solution is made up with a state machine, timers, a multiplexer with data of letters to write. Interconnecting blocks are the interconnection of blocks are made in the main program. That is the top program. The LCD specifications say that we have to wait for power up for a minimum of 15 milliseconds, following by initialization sequence, and then we have to write the characters. Here we have the initialization process. Here we have the orders. We have the commands to the LCD. We have to look close to the write data to RAM that has a 1 0 command followed by the data. And here we have the codification of the data in order to write the characters. We use a pre-made driver that simplifies the initialization, simplifies the data and characters transfer. We have to follow an initialization sequence and a time diagram to write the characters. We have 3 modes: standby mode, also we have an initialization mode, and the mode to write the characters and give orders to the LCD. Here we have initialization process to fire the initialization process. Here we have the sequence. Here we have the transaction timing of the LCD. And here we have a transaction sequence. Let's take a look at an example of writing characters. We have first to power up sequence. Then we have an initialization sequence in this example. Then we have to set the data transfer. Then we have to say which characters we have to use. Then turn on display. Then increment the address, and after that we write the characters. Here's how we write the characters. We have 4 instructions to initialize the LCD and then the writing. W and the other words to welcome. After that we go to the next line and we end the word party. The solution, as we say, a state machine follows a power up timing, drives the driver to initialize the LCD, takes the data from MUX and presets to the driver, and then ends up to a safe state. The inputs is the VC signal, the timers, and the input data from MUX. The output are the init signal, the data, and the bus enabled to latch the data. Here we have two parts. The part from the left is the initialization part, and the part from the right is the data transfer part. In the initialization part, we have in state 0 the init signal goes to 1 in order to make a pulse to initialization process. In data transfer, we follow the cycle 3, 4, 5, 7, 3, 4, 5, 7, and in state 4, bus enable goes to 1 and latches the data. After no more data, when no more data is then we go to state 6. Here we have a simulation. Take a look at init signal that goes in a pulse to 1. That the pulse ends when TMR1 goes high. That is the timer. So the width of the init signal is controlled by the timer. Here we have data transfer, and we can see that is latched with bus enable, and we can see the data latching, and finally we can see the programs. We have 4 programs: finite state machine, timers, the multiplexer with the data, and the top program that interconnects all the blocks. Here we have the top program that interconnects. Here we can see the interconnection of the finite state machine and the timer. Here we can see the driver. Here we can see the multiplexer with the data hello. Here we can see the timers. The timers are like that. They are going to a pulse to 1 when time's out. And finally the finite state machine that has 2 parts. One part is a register, is the upper part that has two parts, the power on part and the next state part. And after that we have the logic, the transition logic part that says what's the next state of the state machine. And here we got the end of the presentation.